this computer, share screen. Yeah, so somebody asked me on LinkedIn the other day, hey, I've got the Google Analytics search query report, and actually, no, Google Analytics site search report. Let me just explain to you what that is. Of course, they give no examples. I don't want to log into an actual account, but for the most part, what this report does is it lets you track what people are actually searching for on your website. So in this case, let me just open the image a little bit larger. Right, okay, so in this case, people were searching for studio, color, portrait, hair, leaves, snooker table. I don't know what this is. It's just some website. But I guess they had a lot of data, and what they wanted to do was say they wanted to group the keywords by the first word in the keyword. So in this case, if there was a keyword called color portrait, it would get grouped under color. If there was a keyword for like hair dye, it would get grouped under hair. Or if there was a keyword just called snooker table would belong to it. So I said, hey, yeah, just use Python and do it. And I realized that people might not know how to do that. So I figured, hey, maybe I'll just write up or code up a little example about how you might do that. And I'm not going to use data from GA, but I will use just some data. So I'm just going to borrow Peter Norvig's the 250,000 most frequently used bigrams with counts. So I'm going to get that. And let me just go back. I don't want to load this entire thing up in my browser. I'll save link as. I'll just download it. Downloads counts to w.txt. Okay. I should have that file now. And what I'll do is I'm just going to start a Jupyter notebook. So if you're not familiar with Python, Jupyter is something you'll call a REPL, or an interactive sort of development environment that you can use. I'm using Anaconda Python. So I'm using a Python 3.6 virtual environment. Go to Anaconda, download the newest Python 3 if you don't have it yet, and a lot of packages will come already in there. We're going to use Pandas today, so let's get it going. So I'll make a new notebook. I'm just going to call it, what should I call it? Like Python keyword grouping strategies or something. Keyword grouping strategies. And one thing I'm going to do, I need pandas. For now, I guess that's all I'll use. And let me just inspect the file. What do we even have? So I'll say with open, so it's in my downloads folder, count. So we'll open that file. And you could put, we're going to open it to read it, but I think that's implicit as f, and we'll say data is equal to f.read. Right, okay, so now what is data? The length of data, let's just check out what data is. We'll get the first 100 characters or 100 elements. Okay, so yeah, I mean, it's there's a lot of stuff in here, but it's there are tabs and there are new lines. So maybe what I'll do is go back up to my read statement, and in order to improve the situation, well, actually, if you print it, the new line should sort of disappear. So we can at least take a quick look at it before we clean it up. Look at the first 1,000 characters. Okay, sweet. And maybe I'll just say data is equal to x.strip for x in data. And now if I clean that up a little bit, we'll see what type is data now. It's a list, which is good. So let's look at the first 5 elements. That's not what we wanted again. Or is it? No. X dot. right? That's just the first 5 characters. We'll look at the first 100 characters. And what we need to do is, you know what, eliminate, what do we need to do? We need to get rid of this new line character. And maybe, oh, I got it. So we need to actually split this on a new line here. And now we need to clean it up further by saying, you know, x dot maybe strip for x in data. And now we'll check it out. Nah, maybe x dot replace tab character with nothing for x in data. All right, but we still have the issue of this numeric value, so there was clearly something to that. So we're trying to figure out how to parse it. I guess it actually is tab delimited. So maybe what we actually need to do, just take a look at it again. And what do I need? I need the keyword, and the frequency is equal to data.split on a tab. List attribute has no attribute. Oh, list object has no attribute split. Right. So data, what is data again? Data is just this thing. Just look at the first 50 characters, so it's a little more brief. All right, so what do we need to do? I need to essentially get these into, all right, I'm going to avoid making it complicated. I'm just going to say rows is equal to a list, and I'll say for row in data, rows.append, then I'll just append a dictionary, and I'll say, well, actually one thing, I'll say keyword frequency is equal to row.split on a tab. And then I'll say rows.append keyword is going to be the keyword. I'm just adding a dictionary. And then we'll say frequency is equal to the frequency. And expected 2 got 1. So that didn't work. We just print. And I could have used pandas. I'm just trying to. And we'll just break. I don't want to print out everything. So that's fine. So my original strategy appears to be fine. Let me actually, it was going to error out at some point, maybe not all the time. So I'll just throw a little exception handling in here. We'll try to do that. I don't want to print that out. And of course, missing a lot of code still, right? Too many values to unpack. So we'll just say try, indent the entire block that we're trying to do, and we'll say accept, pass, and we'll just check the length of rows now. Yeah, okay, so that worked. I don't know what the edge case was, but let's just look at the first 5. So we got frequency, and we've got a keyword. That works for me. Let's get into a data frame just for the sake of utility. Sorry about the slow start there. PD.DataFrame from records. DataFrame from records likes to use like a list of dictionaries, for instance, and I'll say rows. So what do we have now? Great. And what's the shape of the data frame? Right. All right. So let's check it out. So now what do we want to do? We kind of want to, well, I need to group by the first keyword in this data set, right? That's my overall goal. So one way I could do it is just create a new column which contains that keyword. So what I'll do here is I'll say something like df first term is equal to df keyword.map, and I'll just use a lambda function here and say lambda x, and what that does is it basically goes row by row by row in this column, and I can expose whatever's in that row using a lambda. So now whatever's in that row, as I iterate over whatever's in the column, as I go row by row by row, I'll have access to an X. And I guess really I just want to split. So see what that looks like for now. Okay, so if I don't pass in a separator, it'll just split on a space. And what I'd like to do, of course, is just get the first element. I could run into an index error here. I did not get an index error, so sweet. So now it's actually pretty simple to sort of proceed past this. What we can do is just say something like df group by, and I'll just say the first term, and I'll apply a function. Well, what I'll do is after grouping by, I'll grab the keyword column and apply a list. And what this is going to do is it's going to come back with all of my unique first terms, and it's going to go through the data frame, and it's going to find all the other terms in the data frame that start with it effectively. So maybe what I'll call this, and like, 0, 0 end, 0 as, 0 at, zip end, zip code, zip codes, stuff like that. So maybe I'll just call that, out is equal to that. And of course, look, if you're running out of RAM or you don't have a powerful machine, I have 32 gigs of RAM, but you have DataFrame now, you have out, so you're just chewing up memory. Just something to keep in mind if you got a crappy computer. Let's just check it out now. What is out? It doesn't look like a data frame right now. I'm just gonna pass 2frame over to it. So it is not a Pandas series, it's actually a data frame. So now what do I want to do? Maybe I want to check out, I kind of want to check out the terms with the most variance having that root. Maybe we do that, okay? And what could we do? How could we figure that out? Well, I'd want to order this entire thing by the length of this column. So, look, when in doubt, don't reinvent the wheel. Just say out keyword length, or, number of keywords, number of associated keywords is equal to out at keyword, and I'll say map lambda x, and we're just taking the length of x. And then we'll take a look at it again. Hang on, my dog wants to come inside. Give me a second. He's not happy. He's stuck outside. It's a travesty. Come on, dog. Come on, Chance. Let's go, buddy. Okay, pal, you're inside. Okay, the dog is in. Mission accomplished. All right, back to the thing. So now we have the length here, and maybe just for the heck of it, we'll say out.query, and I'll say number of associated keywords, greater than 10. So now we can kind of inspect, and maybe what we can further say is sort values by is equal to that, and we want to go, I think, keyword argument ascending equals false. So yeah, and I guess it's not surprising, right? The, to, for, and a lot of these are stop words. Some of these are not. Maybe look at the last 10 rows. Raw touch bars. And if this was going to be a more complex expression, we could just do that to not violate PEP 8 or some code quality standards you might be following. So that's kind of neat. Now, One thing we lost in this entire exercise was the frequency of each word, right? Like I don't, like now I have the first term, I have all the associated keywords, and that's it. I don't, like, what's the frequency total for each first term group? So let me give you one way to do that. And I guess you could apply this reasoning to any other metric that might exist about these keywords. So anytime you're trying to do some sort of a lookup, that means you generally want to use a dictionary. So what I'll do is just say keyword frequency dict is equal to dict of zip of, what do I want? I want df keyword and df frec. So now that'll create a dictionary where the key, so I'll highlight it, right? I'll make a list of the dictionary keys and check out the first 100 and more, maybe items, right? So now we have this dictionary structure that we can use. And now maybe I'll make a new column. And I kind of like this programming strategy with Pandas. I think it lets you do some relatively complicated stuff without having to think past any given step, which could also get you into trouble, I guess. But let's finish the job here. So what do we need to do? We need to say maybe out total, or maybe just out term volumes. What is that going to be equal to? It's going to be equal to out keyword. And we're going to, maybe we'll see if we can do it with a lambda. We might have to write a function. We'll say lambda x. And x is going to be a list. So we'll say j for j in x. And that j is going to be a keyword. So we'll want to say keyword frequency dict dot get j. And we'll hope that runs. And yeah, that ran fine. Why did that run so quickly? Because it's very fast to look things up in a dictionary. It's kind of independent of the number of things in a dictionary because it uses hashing. And the hash just points you to a position in an array, which is fast. So now we have that. And yeah, so I guess let's look at it again now, because we're just looking at like some like unigram type things. Okay, so now what if I wanted to figure out the sum total of the term volumes? Well, up here, it's just a list, right? So I could call sum on it. And that would still, I think, be okay. Didn't like what I did there. What was the problem with that? Let's actually just check it out. Let's just say out term volumes dot map lambda x sum of x. So we get a type error on unsupported operand type for int and string. So I don't know what row threw that error. One thing we could do is just write a function and say define sum term volumes. I'm going to pass it we'll use a row. And I'll say try return sum of the row, except just return row. Or we'll just return check me later, something like that. And then what I can do is I'll just say out term volume sum is equal to out.map. Out dot term volumes.map, and we'll pass it the name of the function. And what that does is it will apply this function row by row by row to the specified column. What is the specified column? It is this thing. So now the error will be handled, and I'll just keep using this as a kind of a reference point to check the data. Check me later. Right, so what are these things? I guess it boils down to, like, I can sum a list, but if the type within the list is not amenable to being summed, it's no good. So let's just look at it, something. Yeah, okay, so term volumes, I'm just looking at the 1299th row. If I look at term volumes, oh, it's a string. So it's a string. So how do I handle that? Well, I think it's probably easiest to do it up here after the dictionary get lookup operation is completed. Cast it as an integer. And that seems to do the trick here. And I'll need to rerun this. And now I'll have that sum. So yeah, I don't know. Thought that was kind of neat. Sorry about the little kerfuffle here with reading in the data. Let's try to actually read it with Pandas, see if it would have made any difference. Whatever, x is equal to PD, read CSV, and we'll go into, whoops, down, that has to be a string. Go into downloads, and I'll grab count to W. We'll just see what happens there. Yeah, and maybe I'll say separator is equal to tab. Yeah, so that would have been a lot easier, and X dot columns would be keyword and frequency. And yeah, that would have been a lot easier, but nonetheless, I think it was a good thing. If you haven't written a lot of Python to see the pattern of manually handling this and working with pd.dataframe from records, which is handy if you could generate a list of dictionaries. And yeah, I don't know, that's kind of cool. So yeah, in the end, hopefully that's a reasonable solution to grouping. I'm trying to think of any other cool things we could do here. You could create groups based on, I guess, the presence of any word or any two words. It need not be the first term. You could try to generalize it to the first n terms if you had to. Although these are all bigrams. So, you're not going to get more than two words if they're all bigrams. I guess you could do stop words or something like that. But yeah, hopefully that helped y'all out with the mechanics of data munging, or was at least interesting. See you later.